Hello everyone, welcome to Tech All. Today we are going to solve the day 22 of September LeetCode challenge. So today's problem name is maturity element 2. So let's try to understand the problem first. Okay, so what they are saying here, we will be given one integer array of size n and we need to find all the elements that appear more than n by 3 times. So what that means? So if you check that example, right, given example 1, that here my array size is 3 and I need to find all the elements which will appear greater than n by 3. N is the size, right? So 3 by 3 is 1. So I need to find all the element where those element will be appear more than once, right? Means frequency will be at least 2. Okay, so here we can see that we have only one number, that is 3, that is appearing twice in the array, and that is 2 is greater than 1, right? So we are going to return 3 here. Okay, similarly for the second example also you can check that here my array size is 8, so 8 by 3 is obviously 2, so I need to find out all the elements where the frequency is more than 2, that means at least 3. Okay, 3 or more. So you can see that 1 is appearing 3 times and 2 is appearing 3 times, so we are going to return 1 and 2. Okay, so this is the problem statement. So now let's try to identify some solution. Okay, and another thing we need to keep in mind that we need to design one algorithm which can be run in linear time or linear time and order of one space. Okay, so that means we should not use any extra space to compute the frequency. Okay, so let's try to identify some solution for the same, then we will try to optimize the same. Okay, so one basic approach we can use, that we can run 2 for loop and we can keep checking the frequency for each and every number. So what that means, so suppose I will start with 1 and I will check the frequency, I will check that frequency of 1 in that array, right? So I will start from 0 and I will check all the rest of the element, and after that I can decide, okay, so this number is appearing this number of times, so then we can decide the frequency, right? Is it greater than n by 3 or not? If yes, then we are going to add that. But in this case, we are going to iterate through the array. For each and every element, we are going to iterate it, right? So in that case, our frequency will be obviously order of n square, because we need to use nested for loop, right? So that, but we are not using any extra space. So in that case, the space complexity wise it is okay, but if you check the time complexity, then that is not expected, right? We need to solve in linear time. So this first naive or brute force approach cannot be done here. That will be our first approach. We can do another approach. So probably we can take one hash map or any array kind of thing, right? So we can take on any array or hash map and we can scan the whole array. I will scan only once and I will update my frequency in my hash map. So I will probably take one hash map and 1 will be my key value, and in the value section I am going to update my frequency. So I will scan the whole array, and after scanning the whole array I can see that my frequency of 1 is 3. Similarly for frequency of 2 will be 2 and frequency of 3 will be obviously 3. Okay, then we can easily identify these two numbers appearing to more than 2 times, so we can return this. But again, in the second approach, if you use hash map or array, that is, the time complexity will be obviously order of n, since we are going to scan the array once. But in terms of space complexity, that will be also order of n, because we are going to use extra map, right? Map or array, whatever. So that will be depend upon our size only. Okay, so the second approach also cannot be applicable for this one, since we are using extra space, because we need to solve it in order of 1 according to their requirement. Okay, so now what else? So let's try to think some other solution also. So I think there is one algorithm called name Boyer. Okay, so the third option is we can use this algorithm, Boyer-Murray voting algorithm. If I am going to use this algorithm, then I think we can solve it in linear time and without using any extra spaces. Okay, so we are going to solve this problem using this Boyer-Murray voting algorithm. So what is the algorithm? Let's try to understand that first. Okay, then we will try to design solution. Then we will try to write the code. Okay, so what this algorithm says, suppose my total array size is 8, right? We are not going to use any extra space. So how we can identify? So if you look into this array properly, if my array size is 8 and I need to find all the number where my frequency will be 8 by 3 greater than 2, right? That means we need to find all the numbers where the frequency is greater than 2, not equal to, it should be greater than 2, that means at least 3. So that means I can know that at max, for this array, at max we can have two numbers where the frequency will be greater than 2, right? Because you can see that this is one number and this is my second number, right? So these two numbers. So at max we can have two numbers. In some scenario we can have only one number where the frequency will be greater than 2, right? So if we check this example, right, here my frequency of 1 is 4, but for 3 and 2 frequency is 2. That's not matching this condition, right? So in some scenario at max we can get two number for this particular 8 length, right? And in some scenario we can get only one number where the frequency will be n by 3 greater than n by 3 or 8 by 3, okay? So we are going to use this logic to solve it. So that means I know for my n by 3 we can have at max two numbers. It's never can be more than 2, right? Since suppose 8, right? So if one number appears 3, another number appears 3, then remaining length is 2, right? So it's not possible in any scenario that there can be 3 number. At max it can be 2 number always, or in some scenario it can be only one number also, right? So how we can solve it then? Then probably we are going to take two variable. One is the number 1, that will be my candidate 1, and another one will be number 2, okay? Then we are going to take another two variable where I am going to keep tracking my counts, right? So number of time or number of time that particular number appears in the array, or frequency kind of thing, okay? So basically we are going to four variable, two candidate number and two counters for the same, okay? So now what I will do, I will start scanning from here, right? Probably in the first location, right? Now I will check. So initially everything will be 0, right? This 4 value will be 0, okay? So at first I will check, okay, I will pick the first number, right, 1, and I will check, okay, is my number 1 is equals to 0? That means we are yet to find my first candidate number, right? So if it is 0, then we can directly assign it to 1. So I can think, okay, 1 can be my one number where my frequency will be greater than 2, okay? So after that again we will move on and we will pick the second number, 1, right? Now again I will see, okay, that means I will at first check, is num still 0? I will see that it's not 0, it is 1, right? So that means we found two numbers. So my counter for number 1 will be increased to 2, okay? So now again I will pick this one. Again I will see it is already there, right? We already calculated that in the number 1. So again I am going to increment my counter, it will be now my 3, right? After that again here we will see my next number is 3, right? So what that means? 3 means I will see that, okay, I already found my first number, that is that can be 1. There is a possibility, it's not sure, but there is a possibility that one number can be 1. And in this case I can see that my second candidate number is still 0, right? So I can initially assign 3 to that. So I can think that, okay, 3 also can be my number or candidate number, right? And again we are going to increment our counter for the same, it will be 1 plus. Now what next? Now we will move forward and we will see the next number is 3. Again I will see, okay, it's matching with number 2, right? Then it should be 2 plus. That means we found this number twice. Now again we will move further. So here I will find my next number is 2. So in this case I can see we did not pick 2 as a candidate number, right? Initially number 1 is 1 and number 2 is 3. So we did not pick 2. So we are not sure that it can be my candidate number or not. So what I will do, I am going to, in this case, so since it's not matching with number 1 and number 2, I am going to decrement the counter in both scenario, right? So again it will be 2 after decrementing 1 and it will be 1, okay? So now again I will find my next number is 2. Again I can see there is no number in our candidate list. So again I am going to decrement it, right? So after decrement it will be, my counter 1 will be 1 and my counter 2 will be 0. Now the interesting part, the last number, right? Here I will go. So for 2 again I will see that 2 is not there in our candidate list still, because in number 1 we have 1 and number 2 we have 3, okay? So what I will do again, but in this case I can see that counter of my second number is 0, okay? That means as of now we don't have any number as a second candidate, right? It's 0. So I can think, okay, 3 can be my one probable answer since my counter 2 is 0. So I am 2 can be my one probable answer, right? There is a probability. So I will reassign the num2 with 2, right? So then we are done. So here our counter will be obviously at last for C2 counter will be plus 1 then 1, right? So again, after the iterating this or iterating or scanning through the whole array, I can see I can get two probable number, candidate number you can say 1 and 2, but it's not sure, right? We still need to recalculate its frequency and we need to check the logic. Then it's pretty straightforward, right? Again, I can run one for loop and I can start scanning from the initial position. I can then check the frequency of these two numbers 1 and 2, right? That will be easy. For that we don't need any more extra spaces. Then we can decide that whether it's greater than n by 3 or not. Okay, so this is the approach we are going to follow today. So let's quickly write the code for using Java. That will probably give you much better understanding. So as I told you, I am going to take two variables. One is the num1, you can say. Initially I will declare it as 0. Again another one will be our num2. Again it will be 0 only. Okay, apart from that I need two more counters. So let us name it as C1 or counter 1. It will be initially 0, and I need another counter for the second number. It will be again 0 initially. Okay, so what next? Now I need to run one for loop to scan the array, right? So let's take the enhance for loop here. So int num, and we are going to pick one number at a time. After that I will check that, okay, I pick my first number, right? That's 1. Now I need to check that is it still equals to 0 or not. Okay, if it is equals to 0, then we can assign one number as my num1, right? So I will check if my counter is equals to 0. That means we have not found any number with we have not found any candidate number, right? So we can assign that particular number as my num1. Okay, so it should be num1 equals to C1. Okay, then if I see this, if this condition is satisfied, then we don't need to execute the further step. We can directly continue from here, right? Apart from that, we also can check, we need to check that is it, and before that I need to increment my counter value, right, since I found one number. Okay, else, or if we can write another if condition where I will check if my C2 is equals to 0. So in some scenario it can happen, right, that my counter 1 has some value but counter 2 is still 0. That means we can assign another number as my second candidate number. Okay, so it should be num2 equal to C2, and we are going to increment our C2 counter value and we can continue. So we don't need to execute the further step, we can directly continue and check the other numbers. And there can be some scenario also, right, if suppose in this case, right, for second time, right, I can see that num1 is already there. So in that case we need to just increment our counter. So let's write those condition also. So if C1 equals to num, then so it should be num1 should be equals to num, and again it should be equals to num. Okay, and if I see if C1 and num is equal, then we can directly increment our counter and continue. Okay, so it should be not C1, it should be num1 equals to num, then we can increment our counter and we can continue same. Okay, else we need to check the same for also num2 also, right? So if I see my num2 is equals to num, that means we can increment our C2 counter and continue. Okay, so it should be continue, and again it should be continue also. Okay, and suppose it's not matching, so suppose where, right, in this case, right, I can see that I already have one number as num1 1 and I already have another number as my num2. So if it is not matching, then we need to decrement the counter, both counter, right, since it's not matching with either 1 or 2. So at that case we are going to decrement C1 and we are going to decrement C2 also, right? So this for loop using this for loop we can get two probable candidate number that can be our answer, right? Now our next step will be we need to find out the frequency for this num1 and num2, right? So again we need two more variables to check the frequency. So probably we can reuse the C1 counter 1 because we are not going to use that anymore, and we can reinitialize to as 0. Now again I can run another for loop, and let's do that. So it should be nums, and I will check the frequency here, right? So I will directly check if my num equals to num1, then I am going to increment my C plus C1 plus plus, and else if I will check that num equals to num2. In that case, I am going to increment my second counter, right, c2 plus plus. And after that, I need to check the condition, right? So I will check that my c1 is greater than what my array length, right? So it should be nums dot length. In this case, we are checking by 3, right? If it is greater than 3, then we are going to add, and we need to check the same for num2 or second number also, right? If c2 is greater than nums dot length by 3, then we are going to add this number in our result list. So let's declare one result list also. So let us declare an array list, and we are going to store integer only, and let us name it as result, and let us initialize as new array list. Okay, so now we are going to add it in our result. So I can see that if it is greater than this particular frequency, then I am going to add result.add, and I am going to add my num1. Okay, and similarly we will add result.add num2. Okay, I think that. Okay, I think we need to return the result also. So we add this return result. Now try to compile it and check whether it's compiling or not. Okay, I think it's compiling and it's giving us expected answer for the first test cases. So let's quickly submit it and check whether it's giving us the expected answer or not. Okay, it's not. Okay, I think it's failing because we need to change the code, because let's try to understand why it's failing. Okay, so suppose this is my input, right? And here if we check this condition first, then what happened? So at first pass we will assign 8 as number 1, and for the second iteration I will see again it's 8, but again I will see that c2 is still 0, right? So in that case we will assign again 8 to num2, right? So that's wrong. So basically we need to at first check if it is matching, right? If it is not matching, then we can check for c1 and c2 countervalue, right? But initially we should check that is that number already present or not, right? So let's put these two statements first. Now let's try to submit our answer and check. So what will be the time and space complexity here? So you can see that we are not using we are using 4 variables, but that is constant irrespective of my nums length, right? So in this case we can say that my space complexity is obviously order of 1, and in case of time complexity we are running 2 for loop, but those are not nested for loop, right? So in this case, in Oath case scenario also my time complexity will be order of 10. So we are able to solve it in linear time with constant space. Okay, I think that's pretty much for this video. If you like this video, please subscribe to our channel, and if you still have some doubt, you can ask me in the comment section. Thanks for watching. Bye bye.